Hello, I made a video a while ago where I used an Arduino Uno and this clever UnoJoy project to have the Arduino function as a USB input device, and you can hook up all sorts of analog inputs and also just binary button inputs, and you can have that to function as a game controller to play a computer game, which is one of the main purposes of the UnoJoy project, I think. And in that particular video I did things on Linux because it's easier for me to make this video recording stuff on Linux, and also because I use Linux as my main computer and I wanted to play a game which is a radio controlled helicopter game, and for that I wanted to use the 4 channels of a radio control transmitter. So I had the receiver feeding data into the Arduino so I could do things wirelessly. And at the end of that video I made a sort of a promise to do this also on Windows, because the Windows way of doing things is a little bit different and it's a little bit more complicated, as you'll see when we go through it. But what I'm going to do, the reason that I want to use it on Windows is to play a driving game, and I wanted to have a steering wheel, so this is my steering wheel here. I'll also need a accelerator and brake, but we'll do that later. So the actual input side of it is going to be quite a bit more simple this time, because I'm not going to have any wireless stuff. So I'm just going to have 2 plain old analog potentiometers like this to use as input. But the procedure is roughly the same. And just to recap, if you haven't seen that other video, which I will put a link to here, basically, instead of uploading a sketch onto the Arduino, the main chip of the Arduino, we need to upload a sketch onto this other little chip here, and that will tell the Arduino that when it's plugged into, it will tell the computer that it's a game controller instead of an Arduino. And to do that we need to be in a special mode called device firmware update mode, and we can do that by, you can get all the gory details by watching my last video on this topic, but we just briefly short the 2 pins on the left side there of the 6-pin header, and then we upload the sketch to this chip rather than that chip. So I won't go on too much about that, all those details, but we will need to look at the procedure for doing it. So if you go to this page, you can get to here just by googling UnoJoy and you should find this. And then if you go to this getting started page, you will find on there a link to a few things that you need. So obviously you need the Arduino IDE before you can do anything with Arduino, so you'll have to have that installed. There's some information here showing what I just said basically. And you'll also need to have this the Atmel flip tool, which you can get by clicking that, and that will take you to this page here. And then come down and you'll need to get one of these ones for Windows. If you already have the Java runtime environment included installed on your computer, you can probably just get this one here. Sorry, this one. Otherwise you can just get that one. So install those 2, this and the Arduino IDE, and then you would go to downloads on the main UnoJoy section, and this is the one that I got here, UnoJoy for Windows, because I'm using an Arduino Uno. You can also do this with a Leonardo and a ATmega as well, I think, the 2560 board as well, I think. Anyway, so let's flip over to Windows now, and here are those things that I have downloaded, and I've already unzipped the UnoJoy project and this other thing that we'll get to in a second. But let's just have a quick recap of the procedure for turning our Arduino into a joystick. So if I go into this UnoJoy Win folder, we'll go down here and we'll see turn into an Arduino and turn into a joystick. So these are the 2 batch files that we can run to do whichever turning into that we're trying to do. And over here on the left you can see at the moment my Arduino is plugged in, showing up as COM13, and it's showing up as an Arduino Uno. So this is the state that things will be in before you start doing all of this stuff. So to turn our Arduino into a joystick, we'll run that batch file, but first, while it's still in Arduino, we should upload a sketch to the Arduino to have it read in the inputs and relay them as if it was a gamepad. So that is found in this UnoJoy Arduino sample folder, and this is just a regular Arduino sketch that we're going to upload to the main chip on the Arduino as normal. So everything's normal at this point. So if I just open the Arduino IDE to have a look at this, we don't really need to look at it at the moment, so I'm just going to check that I'm doing Arduino Uno on COM13, and then I upload that sketch. So this is going into the main Arduino chip at the moment. Let me just check that that looks alright. Okay, that's good. Now when we've done that, we can go back to this main folder of the UnoJoy project, and I'm going to get ready to turn into a joystick. Actually, I'm going to intentionally forget to do something here. I'll just run this so you can see what happens when you forget to do something. So we have a bunch of red text, and it says attempting to reflash for an Arduino Uno revision 1 or 2. Fail, trying for Arduino Uno revision 3, fail, fail, fail. And then it says, is the Arduino plugged in? Yes, it is. Is it in Arduino DFU mode? Oh, no, it's not. So that's what I forgot to do. So I'm just going to click any key to exit that. And to get it into DFU mode, as I mentioned just before, you just have to short these 2 pins on the left side there. And you should see this light sort of flicker. I think it goes off and then it comes on again or something. We'll see what happens. Oh, it flickers a little bit and then it comes back on. So now when I try turning into a joystick again, we see lots of green, and green means good, and everything looks great, and it says now you need to unplug the Arduino and plug it back in, but it will show up as a joystick. Press any key to exit. So now if I unplug that and plug it back in, according to the documentation, you should see it showing up here as UnoJoy joystick or something like that. Now I've never seen that. I didn't see it on this computer. This is my laptop computer here, and I'm pretty sure I didn't see it on my other computer, or well, the Linux computer that's Windows when I changed the hard drive. I didn't see it on that one either. But don't worry, it's most likely still there. You can try this too if scan for hardware changes. Oh, that's interesting. But it doesn't. I tried this before, but it doesn't. It still doesn't. Never show up here. Yeah. Okay, so you may see that, but don't worry. I think we'll still be okay, because if I go back to my folder where I put the things that I downloaded. Yeah, unfortunately, on Linux, this was as far as you needed to go. You could probably start using it as a gamepad now. But on Windows, what happens is, at least for a lot of games, they want to use an Xbox 360 controller, which this is obviously not. So what I've been using to get things to work is this really neat tool called... where are we? Oh, was it gone? Here. Okay, so there's this tool called Toka Edit or something, and you can get this by Googling for Xbox 360 emulator, or maybe you could just type that in, X360CE, Now this is a really neat little tool, and the reason that this tool exists is that a lot of games like to use the Xbox 360 controller because it's a very common standard, at least on Windows for games. But if you're doing anything weird like we're doing in this video, or if you just don't feel like spending $45 on an Xbox 360 controller and you bought one of these cheap, nasty knockoffs like I did for $16 instead, you may have trouble getting your games to run if the game is expecting to see a real Xbox 360 controller. So originally I first came across this emulator software for to get this gamepad to run, but it turned out to be very useful for getting the UnoJoy to run as well. So all I've done to get this is I just downloaded one of these, whichever one is appropriate for your computer, and that's what I have here, and I just unzip that into a folder on in here. So when you unzip it, you'll just see this exe file. That's all there is in it. So I'm going to run this in a second and show you how the setup looks, but I'll just also, before I do that, show you what the output we get from that is. When you run this and you set the settings correctly, it will output a DLL file in this same folder and another file, an INI file, which contains your settings. And you'll take those and you'll put them, in this case, the first time I tried this was to play Spelunky. So this was in Steam. If you have any games from Steam, you'll probably find them under Program Files, Steam, App Cache. Nope. Where is it? Steam Apps, that's right. And then Common, and then Spelunky. So if I go into the Spelunky folder where Spelunky is installed, you'll see we have this DLL, X input 1.3 DLL, and it's not actually made by Microsoft. As you can see when I mouse over it, it says company x360ce.googlecode.com, so that's obviously not the Microsoft's official one. And then we have x360CEINI. This is just a text file that contains some settings that are specific to your controller. And this X input DLL is here because the way that dynamic loading of libraries works on Windows is that whatever folder the executable file is in, it will first look in this folder to see if it can find any of the named DLLs that it's looking for. So this file here I think this will be in C Windows System or something like that, which was where it would normally load it from. But you can override that or bring this file into a higher priority in the loading list by just placing it in the same folder as the exe file itself. So this DLL is going to be used instead of the normal Windows one. So that's going to override the normal behavior, and it will treat our fake gamepad as if it was a real Xbox 360 controller according to the settings that are in this file. So when you're all done with these settings, I'm not going to come back to this again, but just keep in mind that when we're done with all the setup that we're about to do, you'll need to take these two files and put them into the same folder as whatever game it is that you're trying to run. So if I wanted to play Spelunky, I'd have to put it in this folder, and if I wanted to do it with Terraria, I'd also have to put it into this folder as well. So wherever you need, whatever folder the exe for the game is in, that's where you need to put it. Alright, so let's run this and see what happens. Now it's saying the X input 1.3 DLL was not found. Do you want to create it? Whoops. So I'm going to say create. Let me just cancel this. If you're using this just on the off chance that you do have one of these knockoff controllers and you're trying to set that up instead, what you can probably do at this point is search automatically for settings and also search the internet checkbox, and it will most likely find the settings automatically for you. This tool is quite well maintained and very popular, so give that a try. I'm going to cancel that because I know that my crazy Arduino thing is not going to be found anywhere else, so I'm just going to cancel that. Alright, so back to here. I'm going to click create because I want this X input 1.3 DLL to be created. So now you can see we have the two we have those two files that we saw in the Spelunky folder just before. Did that crash? Oh. Alright, cancel. Okay, this is also okay. At least I found that it doesn't matter. So I'm just going to click OK through that. Now, the first time you run this, you'll probably find that there's a red marker next to this controller tab here, and all of the buttons are all grayed out on this. It's like a preview display, so you can see what buttons it thinks you're pressing. But if you go over to the right hand side in the bottom right tab, there is a tab, or there should be a tab called UnoJoy joystick. So this is the first indication that we can see that actually proves that this UnoJoy joystick thing worked properly. So if you don't see this at this point, then I don't really know what the problem would be or how you could fix it. I'm sorry, but I found that at least in the case that both cases that I've tried it for, even when there's nothing showing up in the device manager here, this Xbox 360 emulator program is a little bit smarter and it manages to find it. So anyway, I'm going to click on here, and then we can see some raw values. So you'll probably see the analog values sort of twitching around a little bit, and these are the raw values that it's reading in from all of your sliders or the analog joysticks. And as I said, oh actually no, sorry, yeah, can't do anything with that yet. Okay, but I found that if I just clicked save here, not necessarily on this tab, just anywhere in this program, just click save and then exit and then run it again, and I just sort of discovered this by chance. I almost gave up on this a few times, but I found that when I saved and closed the program and ran it again, now we can see that the light on this controller 1 tab is green, and the buttons are showing up here in colors. So something inside this program got set a little bit more properly than it was before. And now we can do the next part of the process, which is figuring out which of these axes and buttons are the buttons that we have on our fake controller. So the easiest thing to check is a button, because buttons don't really have a direction. So what I'm going to do is make, so that's the earth, or that's ground there, and I'm going to make digital pin 2 my button A. So the way we can do that is, so this is button A here, and you can manually select what input you want that to come from. But I've found that one really neat little trick that this program lets you do is just click on this record option. Let me just see if I can do this. Hopefully we can see both of these things happening at the same time. Ah, no, we can't. Okay, so what I'm going to do is I'm going to click record, and then I'm going to put the digital pin 2 connection on there. I'll just see if I can do this. Okay. Okay, so now you see button 4 is showing up there. And now if you watch the visual display of button A there, you'll see that by connecting digital pin 2, I'm pressing button A on the controller. Now why is it button 4? I guess that's because if we go back to the UnoJoy sketch, perhaps button 4 was digital pin 2 or something. So digital pin 2 is being given triangle. Triangle? Is it a triangle? That sounds like PlayStation nomenclature, doesn't it? Anyway, so you don't really need to know specifically which digital pin is which, as long as you use that record feature. Okay, so let's see if we can do that for our dial. So I'm going to do the same thing, and I'm just going to turn the dial fully to one side or the other. So I'm just turning it fully to the left at the moment, and I'm going to make this go onto stick axis X. So I'm going to do the same thing. I'm going to do record, and I'm just going to turn that dial all the way to the right, and we can see that it has detected that as IH axis 2, and if I understand this correctly, the I is for inverted and H is for half. If you want to set these manually, you can come down here to axes, and so IH axis 2 would be inverted half axis 2. So this is the one that it has automatically detected for me to be that axis. Now let's see if it got what I wanted. If I turn this dial, doesn't look very good, does it? Nope, that's not what I wanted. And if you want to look at the raw values at this point, you can also see what values we're getting there. So you can see when I turn, the axis X here is this value. It's twitching a little bit there, but it goes from basically 0 through to 65535. Not sure why it's twitching like that. It wasn't twitching like that just before. That's better. Okay, so it's a bit more solid 0 there. I'm not sure, maybe I had a funny connection there. Damn it. Anyway, so that's that axis. Not quite what I wanted though. So rather than IH axis 2, might just try that again. It gave me something else before. It's a bit finicky. I'm going to just try turning it a little bit slower. No. Now it's given me H axis 2, and as I move it, it's kind of jiggling everywhere. Okay, I think I figured out what the problem is here. When you do this record, what it's doing is it's looking at these raw values here, and it's just seeing which one you're changing, and then it's recording that as that axis. But the problem here is that even though I'm changing this one here, my intention is just to change this top X value, the other axes here are all sort of twitching around and they're moving as well. And when I turn the dial a bit, we can see everything's moving all at the same time. So instead of picking out the correct axis, it's just picking one of the wrong ones, it seems. And I think maybe I just got lucky last time I tried this and it picked the correct one. So the reason for that is, I think I commented on this in my previous video as well, is that I only have analog pin 0 actually connected to anything at the moment, and analog pins 1, 2 and 3 are just floating. So you could either connect these to ground to make them shut up, or you could do what I'm going to do, and I just sort of tried a couple of the other axes, and I found that when I set it to axis 3, and now when I turn my dial, we get a much smoother movement of, so I'm looking at this here now again, we get a much smoother movement of that axis. So that's what I want, from side to side like that. It's going the wrong way, so what I actually wanted was inverted axis 3. So now I should have the correct direction and the correct movements. And if you find that it's not going far enough, you might be looking at one of these half axes. So let me just try inverted half axis 3 and see what that gives me. That's funny, it doesn't change. Alright, well, I'll keep that. So that is how you can set up a button and an axis, and then of course you click save, and that will write the settings into this .ini file, so that then you will copy that into your game folder to run. To play this car driving game that I'm going to do, I need another axis to function as my throttle and brake. So I'm going to use this radio control gimbal potentiometer from inside here, because this one doesn't have a return spring, so I kind of want to use this one as my throttle. So I'm just going to connect that up, and I'll show you perhaps one other little thing that you might come across, a problem that you might find that we can work around with this kind of potentiometer. Okay, now I have connected both of these potentiometers to the Arduino. So this is going to be analog 0 and this is analog 1. And I have also, in the emulator program, I have determined that the throttle stick here is inverted axis 2. As you can see, the little green cross here is moving up and down when I move the stick. However, now this is the problem that I mentioned. It's not moving much at all. And the issue here is that just in the way that this potentiometer is made, we don't get a full range of the values. The voltage that it reads on the wiper doesn't go from 0 to 5 volts fully. So these ones here, you often find that they do go from 0 to 5 volts. So we get a full range of readings from the analog read that the Arduino is doing. So what we need to do is calibrate this joystick here so that we do know the full range. Well, it's not reading the full range. We want to know what range it's reading, because we know it's not reading the full range. So one way we can do that is in the sketch that we uploaded to the Arduino that does the reading of these values. If we look down at the bottom of that, we'll see what's going on with these stick readings, and they're all being done with analog reads. So this is my steering wheel, and this analog 1 is the throttle that I'm having problems with. So I want to see the values that I'm getting from that. So what I can do is, in the setup function, I can do serial begin, and having problems with keyboard mappings here. So I can begin some serial output, and then down here, say, I can do serial print line and then analog read A. So A1 is what we want to know what's going on. Now, to get this onto the Arduino, we have to go through that process where we turn it back into an Arduino and then upload it and so on. So to do that, of course, we've got to short that pin again. Actually, I might just close this program first. Alright, so I'm going to short the pin, and then in this folder I'm going to click turn into an Arduino. That should run with lots of greens, and then we upload. Man, there's so many steps. Now I have to do this, and then it should come back as an Arduino Uno there. Now I can upload the sketch. Now at this point I just want to open my serial monitor and look at the values that I'm getting. So what do we got? When I push it right down the bottom I get 620, and when I push it right at the top I get 400. So 400 to 620 is the range it's giving me. So you can see it's clearly not 0 to 1023 like it would be for this type of potentiometer. So what is that, 400 to 620? Okay. Now what I can do is, instead of using the normal range that analog read would give me here, which is 0 to 1023, I can instead use map. So I can map the value that it's giving me from being between 400 and 620 to being between 0 and 1023. Oops. I need a bracket. Ah, damn it. So that should change the range from 400 to 620 to the full range. I might actually just go a little bit lower, 398, and a little bit higher on the high range, 622. So that'll make sure I don't get any negative values coming out of this, hopefully. And then I'll just take away that stuff that I had for my debugging output, like get rid of those, and then I will upload that to the Arduino, and then we need to switch it back to a joystick again now. So we short the pin and then click turn into a joystick, unplug, replug, and then go back to the emulator setup. And with a bit of luck we should see now that we're getting the full range. So back once again, I'm looking at this here. We're getting the full range of movement vertically on that axis. So that'll give us a real good throttle and braking when we're driving our car, instead of just a pathetic one. Alright, well that's about it really. Of course there's a lot of other controls and inputs you could set up for however you like, and if you're watching this video thinking why would you want to use a shitty setup like this, of course the point of this is that this little potentiometer here could just as well be a full-sized steering wheel that you use to turn, to drive, and this here could be a pedal on the floor that you use to, you know, drive your car, or could even be two pedals really. And you know, you could have a handbrake beside you that you use as your handbrake button instead of one of these stupid little wires. You know, you could set up a really nice little system for, say, a flight simulator or a driving simulator. I'm not going to do that, but I'm just saying, like, this little crappy setup here is not necessarily the end goal of something like this. It's you can set up whatever kind of system you want if you put a bit of time into it. Anyway, so for the rest of this video I might just put in a little bit of driving in the Dirt Rally game, and I'll see if I can patch my, you know, fingers doing stuff on top of the video so that you can see that I am actually managing to play the game using this crazy setup. Anyway, thanks for watching. See you next time. 5, 4, 3,
2, 1, go. Left 6, 80 through dip, right 6, into left 4, into right 2 down, jump maybe past junction, left 6 through dip, 200, hairpin left, don't cut, 130, right 6 half long, 250. Caution braking bumps, acute left, don't cut. Into hairpin right. 100. Right 5 half long, don't cut. Into left 4 long. 100. Caution right 6, into immediate hairpin left, up, hairpin right, 60, right 4 times 3, don't cut, and left 2 half long, keep mid, bumps, and left 3 past junction, through gate, right 5 long past junction, crest, left 5, and right 5 through dip, 40, dip, 100, caution braking, turn acute right, don't cut, 100, turn right 1, don't cut, 100 past junction, 60, caution left 5 bump, don't cut, be brave, 60 crest, right 6 past junctions, left 3 long, don't cut, 60 keep right, left 6, don't cut, 80 crest, caution right 3, don't cut, keep in rocks outside, 100 through dip, past junction, turn right 5 cut, 60, left 6 continues for 150, crest, 80 past laybys, caution turn right, don't cut, immediate left 1, don't cut, 170, right 5 long, don't cut, into turn left 1 dip, don't cut, 40 past junction, 80, left 4 long, and right 6 times 3 past junction, opens 100, left 4, don't cut, keep mid past junction, rocks outside, 60 crest, to finish.